folks, and welcome to the workshop. What we've got for you today is a Nissan Leaf motor and a 5-speed manual gearbox from a BMW E46. Now, there's been quite a few people recently that seem to be having difficulty with the concept of how we make adapter plates and couplers and all this kind of thing. Now, I did quite a bit of this back in the early days, but I figure, you know, why not give people a bit of a refresher course on what we're basically doing here for this particular project. Now, this is a Gen 1 Nissan Leaf motor, and what we want to do is we want to get the motor shaft connected to the gearbox input shaft. Then what we need is a way that the bolt pattern on the motor, so the mounting bolts for the motor, will match the mounting positions on the gearbox bell housing. Now, in order to do that, as they say on the cookery programs, here's an adapter plate that I prepared earlier. Now, what this is a piece of 25mm thick aluminium that we basically cut out to the same shape as the gearbox bell housing. Now, this is a plate that I used in my E39 with a DC motor, very same type of gearbox as this, so we can reuse this adapter plate. And it was basically just drawn around with a permanent marker and cut out with a jigsaw. And yes, that was a pain in the neck for sure. But it still got done and worked away fine for the last 5+ years. Now, that means that this plate will bolt up to this gearbox. And we can then locate the motor onto this side of the plate here and basically drill and tap the holes to mount it. So that's one part of the procedure. The second part is that we need to get drive from the motor shaft to the gearbox input shaft. Now, both of the shafts in this case are BMW gearbox input shaft and our Nissan Leaf motor have got splines. Now, fortunately, in the case of the BMW gearbox, we've got this guy. And this is the center of the clutch friction disc that I just basically chopped out. I spared you guys the agony of having to watch me doing that, but that's just a basic clutch disc. And that just slides on here and mates up to the splines of the input shaft. On our Leaf, we have another clutch disc. This one is from a Fiat Multipla van. I think it's a petrol van. That happens to have the same spline pattern. It's not a perfect fit, but it's good enough for government work. And that slides on to our Nissan Leaf motor shaft. And this means now that all we need is the right spacing and something to join these guys up, and then we should be all set. Simple as that. Now, in order to do that, there are some steps that we can take to make life easier for ourselves. So, what we need is something like this. This is a piece of heavy wall tube steel. This is the type that would be used for things like making hydraulic rams and heavy kind of rollers and that. It's a hot rolled steel and is seamless. It's very important that you don't just get a piece of seam tube because that wouldn't nearly be as strong as this. Now, I bought this piece. It was a little bit longer because I've parted a piece off it, but I bought this from a local engineering shop for €20. And it is just a tiny bit smaller on the inside than the smaller of our two clutch discs, which is our Fiat. So that is going to have to be bored out to fit. Now, over on the lathe here, here's the aforementioned piece that I parted off, and we're set up here now with our boring bar, which is quite boring, and we're going to bore this until we have a nice tight fit for our Fiat clutch disc. I will spare you the groaning and the moaning of the machining, and we will come back when we're getting ready to fit this guy in here. Now this is the kind of critical bit. So what we did is we basically achieved a shrink fit of the Fiat clutch disc into the tube by basically boring this to about 0.15 mil too small, and then just heating it with a map torch. Now ideally I would have used an oxy propane torch to get it red hot. I would have got a much better shrink then, but unfortunately I don't have one of those at the minute. So we just got to make do with what we've got. So now that I've that shrunk on, we can basically chuck from the clutch disc. There's enough of a grip on this here for it to not spin. And we can start boring out the other side then to take our BMW, and then we'll be able to do the same thing, heat this up, and yeah, get them all together, and then this will be our coupler. We'll basically weld this up, and that's it. It's not any kind of big deal. Okay, so we've skipped ahead a few steps, but don't worry, we will cover them. Now, what we've got for you is we have our Lexus IS300H inverter, our prototype open source logic board. We just got a 12 volt car battery here supplying us with 12 volt power, and up on the bench there we got just a forklift battery charger supplying about 40 volts DC to the high voltage bus. Over here we have our Nissan Leaf motor, vertically oriented. Our coupler is basically connecting the Nissan Leaf motor shaft to the BMW gearbox input shaft. Got a couple of bolts just holding the gearbox to the adapter plate, but there are no bolts holding the adapter plate to the Nissan Leaf motor. Now the reason for that is that we want to align the two shafts so that they are as accurate as we can make them. Now the first part to this is that we basically sit our adapter plate and gearbox down on top of the motor and line things up just as best as we can. Next thing is we put the gearbox in gear and we just basically turn it manually like this and look for any play or any kind of wobble that might be in there. Next thing that we do is we want to spin the motor. Now back in the old DC days, this was a hell of a lot easier. All you needed was a 12 volt car battery and a set of jump leads, whereas now we need an inverter and, you know, some more gubbins. So got the inverter interface up on my tablet here. We're just going to spin in open loop mode. There's no need for throttle control or stuff like that. We just want to get the thing spinning just so we can look for problems. So let's hit start inverter. Alright, so right now our motor is running at a frequency of 5 Hertz, and we can see up there now that our gearbox drive shaft flange is indeed spinning, and spinning in the correct direction, which is rather important. Now for my next trick, I'm going to get my trusty torch. I'm going to look in there through where the clutch slave cylinder would normally have been. Pardon the head view, guys. What I'm looking for, see if there's anything shaking around in there that really shouldn't be. So is the spline shaft of the gearbox moving back and forth? Is there any vibrations or any tendency in the gearbox to want to move? Because if there were, it would have a pretty serious problem. Now I'm looking pretty good there. Obviously the body of the coupler is not concentric with the internal, so that's okay, because we're not finished making the coupler yet. So let's see if we can speed things up a little bit. It's just running open loop control, so it can be a pain in the neck, particularly with permanent magnet motors. Let me go up to 7 Hertz. Oh, we're losing that. We're losing our captain. We got her back. Let's see if we can squeeze ourselves up to 10. Oh yeah, okay, now we're running at 10 Hertz. Alright, so now that we have our motor and adapter plate lined up at least to where it doesn't fly apart, our next thing that we need to do is to locate the mounting holes from the motor to the adapter plate. Now how we're going to do that is we're going to mark around each one just approximately like that. Take one of our locating punches, that's just a slip fit in there. Take a hammer, now we've our holes punched, well, marked with the locating punches, I should say. We'll lift off our gearbox from the motor. There we go. There we go. Got our holes are pretty much located on there. I'm just going to get my marker, mark each one. Looks as if one of them clashes with an old one, so it's inevitable, I guess, isn't it? So one of them. Oh, there he is. Yeah, he's marked. There he is. And that's it. So there's 1, 2, 5 mounts for our trusty Nissan Leaf motor. So this is our coupler. At the minute it's not welded here, it's just been shrunk on. This is the motor side and gearbox side. So before we do the final assembly, we'll basically weld this up, and I might just grind off some of that excess material, put a little bit of paint on it, and then that's be pretty much us. Alrighty, so we're going to weld up the coupler. I'm going to talk you through just a few of the things that I tend to do on welding these. It's a little bit different to how you might tackle a normal welding job. Thing you want to do, you want to get your welder hot. What we're going to do is we're going to weld maybe about 12 millimeters, flip it 180 and do the same. What we're not going to do is just try and weld a complete seam. The reason we don't want to do that is number one, we'll put too much heat into these clutch discs, and number two, as the weld cools it contracts and pulls, and that can cause these guys to become wobbly And we don't like wobbles. The wobbles of Wimbledon. Or was it the Wombles? I forget. Alrighty folks, so here we are. We have our plate bolted up, couplers welded up. I hit it there with a bit of cold galvanizing spray. I elected not to, as I say, I elected not to go sanding off all this stuff just because I'm on a bit of a time pressure. I also put a bit of this bearing lock stuff on there just to try to help the splines take up slack. And on the gearbox, you may notice in here, I don't know how well this is going to come out, but there's a little spot weld in there on the spline, and the purpose of that is basically this is going to float back and forth a little bit, but I don't want it to hit this tube here because it'll make a horrible noise. So that's about it. I'm going to go ahead and we'll see if we can get our gearbox on here, do another spin, bolt it up, and we should be all set. Alright, let's see if we can sit our gearbox on here. So now we're basically bolted to the motor, but not the gearbox. So, kind of a moment of truth this now. How badly would I have screwed up? And up we go. There we go. Let's screw up totally badly. Oh, now we're spinning. Alright, so we're spinning now. Full speed. Get my torch, we'll have a look in there. Pretty much. Let me stop that here now for a sec because one thing. Well, alrighty, we are pretty much bolted down. Oh, I managed to forget to tighten one of them, but that won't be our problem. And we're looking pretty good. Spinning away. Alrighty guys, here it is. Spinning away, happy as a clam. Keeping in mind that there's no oil in this gearbox at the minute. I've got zero vibrations anywhere, apart from good vibrations, obviously. Yeah, this is it. We're good to go. And that's it. That is a simple coupler adapter plate system. Nissan Leaf motor, 5-speed manual gearbox. In this case, for our trusty Grey Goose. Right, let me stop that there. Okay, folks. So I hope you have enjoyed this little video on our Grey Goose adapter plate coupler motor mounting system. I guess I want to just finish up by saying that there's been some controversy going around some of the forums recently about, there's been some people told that, unless they have accuracy down to wavelengths of light, that their motor is going to blow up and various things like that. So I guess what I want to say is, if you have the capacity to have all kinds of crazy accuracy like CNC machines, Renshaw probes, laser cutters, 3D scanners, all that, by all means use it. There's no such thing as having too much accuracy. But if, like myself, anyone else that's in the same boat, what we just showed you, I have proven that to work in a vehicle guts of 100,000 miles over 5 years. So don't be afraid to try. Well, I guess that's just how I want to finish the video up. So I'll leave you there. There's not going to be many episodes in this particular series, so it'll be fairly short. We will see you in the next regularly scheduled program. Don't forget to like, share and subscribe. Check various links in the description. And until then, happy motor adapter making.